Please welcome Malcolm Ponthacki, Denise Fitzgerald, Mike Vinarsik, and Dr. Ernesto Motola.
Hello, everyone, and welcome to this panel discussion titled Systems Thinking and the Digital Thread, Key Ingredients for Successful Digital Transformation. I'm Malcolm Ponthacki, VP of Analysis Solutions in the Strategy Division at Aris. My portfolio includes MBSE, simulation, and exploring the use of AI ML tools across the product lifecycle. Today, we're joined by three industry experts discussing why a system-centric approach is critical to manage exploding product complexity and to achieve their digital transformation objectives. I'd like to introduce our panelists. Denise Fitzgerald is Group Leader of Mechanical Engineering and leads the digital engineering transformation at MIT Lincoln Labs, where they're building a full lifecycle digital thread. Welcome, Denise. Ernesto Motola is the Senior Manager of the Model-Based Development Department in Toyota Motor Europe, and his mission is to develop and validate new MBD technologies for effective prototype-free development and to drive the environment and process definition with stakeholders for effective application. Michael Vinarsik is Chief Systems Engineer in SAIC's Strategy, Growth, and Innovation Organization. He develops capabilities with an emphasis on model-based systems engineering and supports multiple clients as a senior technical expert. Hi, Michael. So welcome to you all, and thank you for taking the time to participate in this discussion. While we're not planning on a live Q&A session, please enter your questions in the Q&A panel, and we'll get back to you after ACE is behind us. And also, you will find many useful documents under the handouts tab of this session. So let's just jump in. In this section of the discussion, we will explore the digital transformation process. So Ernesto, this one's for you. What does digital transformation mean to you as manager of model-based development and to Toyota as a company? Is it how data is represented or how people work or what tools they use or the role of a low-code platform?
Good morning, Malcolm, and good morning, good afternoon, good evening, depending where you connect. This is Ernesto Moto from Toyota Motor Europe. I'm connecting from Belgium, and I'm working in Toyota Motor Europe, in the technical center from Toyota in Europe. So, well, we develop cars. At least so far, we've been developing cars, and probably if you are into what happens in the automotive industry, there is a big transformation ongoing. Not just we have the usual pressure from diversifying our products to meet more evolving customer demands, while at the same time satisfying more stringent requirements in terms of safety, emissions, and so on, and connectivity. Recently, Toyota, as other companies, announced an evolution of an offering from developing products towards developing products and services. So in general, we face an ever-expanding complexity in our development processes. And even if we could afford to expand our resources to deal with those complexities, probably that would not be a smart way. So I would say, in general, this is what drives digitalization. And maybe we should discuss first what do we mean by digitalization. I mean, we are all connected, having this conference virtually, which probably would have been difficult to imagine a few years ago. So I think our work is basically digital. But throughout our work, there are so many things we do that are so much analog, I would say. Think about, I'm not sure you, but we have still so many things that go through by making phone calls, by searching for documents which are piled somewhere in, even if it's in electronic archives, but kind of searching information, manually processing or reprocessing information, making sure that this information is made available to those who need to consume it. That's a very analog process. It's not very digital. And that's still a huge part of our work, I would say. So for me, at first, the need for digital transformation as a manager in a model-based development, I deal with digital information, is to make sure that this information is provided quickly to those who need at the right time with trustable quality, without all the burden of all these huge analog processes that been kind of typical in many large organizations. So I would say this is the first point. This is what digital transformation is for us. I would say that the very same idea of transformation matches very well with Toyota values. We are the Kaizen company, meaning that we continuously develop our processes to deal with new challenges, to do things more efficiently. So in that sense, I would say complexity is something that can be managed. We can define ways to analyze and overcome specific complexity issues and make our processes more efficiently. We've been showing some application in previous session at ARAS conference about some ways we've been tackling digital transformation of processes. But in general, I would say, for me, digital transformation is a way so that people can collaborate more effectively to be able to deal with this increasing complexity through the correct use of digital resources. That has to do with, indeed, data, processes, workflow, which get digitalized, and roles which get somehow matching those processes. That somehow need to interact or interface with the way people work, and I think this also affects the way they use their tools, including PLM. For MBD, the key for us is to deploy simulation technology. And of course, this has to do with the fact that people would trust a simulation technology that has been validated for certain purposes. That's, of course, part of our work. But model-based development is not just realized by having technology which is capable of doing something. This technology needs to be mated with the correct information to be effective for actual vehicle development. So in that sense, the relationship with different data is a way for model-based development to deploy this simulation advantage to the organization while dealing with increasing complexity. I would say the role of PLM, a modern PLM platform, is, I guess you're interested in that point, is to facilitate this process digitalization, to maintain this kind of flexibility where we can handle effectively the information that we need to be placed in the correct context at the right time with enough confidence for people to consume it without the extra burden of those analog processes which I mentioned before. And therefore, I would say, in a way, PLM is something that should support Kaizen. It should fit the organizational effort, which is process digitalization. Of course, the challenges are bigger than the PLM platform itself. The platform can be a blocker, of course, if it's not flexible enough, but we're talking about making sure that we can break down the processes to the way people would know how to interact, digitalize them. So I would say connect existing tools and processes with the true digital flow so that you don't have to worry about all the analog burden. I'm not sure I talked too much, but I think probably I give you an idea about what I mean by digital transformation.
Thank you, Ernesto. Denise, the MIT Lincoln Laboratory environment and business is quite different from Toyota's. No mass production, one-off solutions, etc. Is your view of digital transformation fundamentally different from Ernesto's?
It's actually remarkably similar. Ernesto, Malcolm, and I had a fantastic conversation a while back, and I think we were actually all surprised that we were saying the same thing and trying to do the same thing, albeit in slightly different ways. Our businesses have different needs, but you've heard this message if you've been listening this morning, and if you just hopefully were listening to Ernesto. It's all about people, process, and technology, and true transformation has to put those in balance. If you used your film camera and you scan the pictures and put it on Facebook or Instagram, you wouldn't be taking advantage of digital technology and digital transformation. That's an analog process trying to marry with a digital process instead of just using a smart device. And you think about that smart device, that was a technology that changed the way that people interacted with each other because now you have a social network. So if you think about transformation like that, instead of like, how do I make a process go from 14 steps to 13 steps? How do I really take advantage of the technology? How does that fundamentally change what I do? And how do I get people to embrace that? And that's the big challenge of all of this. So these model-based approaches are fantastic, and they offer a huge upside, but we have to rethink the way that we work. We have to rethink because these changes cross domains, whereas I was happy being a CAD designer, and I didn't have to worry about the machinist using my CAD model or the next person who receives my technology using that CAD model. Now I do, and I have to put more information into it to make it useful. So it's hard because if your technology development has been siloed, it's really hard. You have to think across domains now. You have to think of work as a stream of work rather than, just a small technology change of using the next greatest CAD system or the next, MBSE tool. And for us, that's where the platform comes in. That for people who aren't experts in systems engineering or CAD or any of those disciplines, you have a platform to go to understand the broader concept, the broader scope of the system. And that's really important because, as Malcolm said, we're doing a lot of concept development. We're doing a lot of prototyping. We have to get it right the first time, because if you put it in space, it's hard to repair it unless you're, Apollo 13 or the Hubble, and ours don't really fall into those categories. So, you have to do it right. The timelines are getting shorter. The budgets are getting smaller. So you have to do a lot of that systems thinking. You have to think up front. You have to plan it right. You have to think through the problem. In all cases, I would say people like to have that reaction and think quickly. But in all cases, I'd also say if you step back and really do that systems thinking, you'll do it better and correctly and not have to do as much rework or rethinking. I loved your comment, Ernesto, about analog thinking. It's so true that it's difficult to. Yeah.
That's where we come from.
Yeah. How many times have you looked through your email to see what decision you made? We have to start thinking of better ways to manage our data, to manage our decision making, to work as a team, and that's everyone in your organization. So I think that's all I have to say, Malcolm. I'll hand it back to you. Sure, I have more to say, but that's all I have to say about this question.
Thank you. We'll move over to the next section in which we're going to switch gears to the concept of systems thinking, how it relates to digital transformation, and why it's important. So over to you, Michael. You're an expert in system modeling, and SAIC is big on making systems model part of the digital transformation process. Given what Ernesto and Denise have just said, what is the role of system models in a digital transformation, and can these models truly benefit the entire organization?
Sure, and I'm happy to tackle that. So thanks for asking the question, Malcolm. And again, system models are this connective tissue that makes this transformation possible. And I'm borrowing some phrases from another presentation we'll have later. but it really helps us to understand the structure, behavior, and I would argue even the context of a system in a way that is difficult to get with natural language or a pile of spec documents or a variety of the other ways we've tried to communicate that information in the past. And so this goes back to the entire issue of the analog thinking that we've been discussing, right? It's that we have to uncouple what we need to do from how we used to do it. And so I'm a leading practitioner in using SysML, a standards-based modeling language purpose-built for expressing information about a system. There's other alternatives as well. But when you construct a model of the system using one of these purpose-built languages and tools, you can validate and query it in ways that it's difficult or impossible to do with natural language or traditional diagrams or whatever. And so you can get a consistency and completeness assurance that can be done automatically. And so the term I like to use is that you squeeze the model. As you crop up more errors and information warnings and burn those down, you end up with your behavior, structure, interfaces, and parametrics all in sync. And then this combined pool of information can be used through the entire life cycle from concept through disposal in a way that you can't get if you just are bill of materials focused. And again, we'll be talking about this a little later. But the point here is that you've got this bedrock foundation. And in some ways, it holds systems engineering to a higher standard because gaps and errors and the ambiguity and the fuzz in what we've been doing up to this time, it pops right out when you start modeling and have validation. You can't hide ambiguity or this fuzziness. It really forces a lot of clarity of intent that benefits the entire organization. Let me give you an example. My son just presented at the Nkosi Great Lakes Regional last week about automated failure mode effects analysis using one of SAIC's profiles that we release freely. And he showed how a simple table drawing information out of the model could show the failure mode that the Galileo probe had. So Galileo was a space mission. It got delayed. They had to replan the trajectory. Turns out the lubricant in the antenna dried up, sort of, and they removed the motor driver that would let them collapse the antenna because they needed that memory space. Again, this is the 80s. Memory was expensive. They needed that space for other things. Well, when they went to deploy the antenna, it jammed and they had no way to recover. Well, if you would have done the architecture in a system model, you could get a table that showed what every function, what does it participate in, and is it part of any recovery from failures, and you could easily make an informed decision. Now, that's not saying that the Galileo team wouldn't have made that same trade-off, but at least we would know beyond any shadow of a doubt they were at least informed of it. And I think that's the real strength of the modeling effort, is to allow us to make these tactical queries that can provide decision makers anywhere in the life cycle relevant information based on up-to-date knowledge about the architecture or other attributes of the system. And that's how we can make sure that decision makers anywhere in the digital thread have the info they need to make an informed choice. So back to you.
Thanks, Michael. I think we may have lost Ernesto. Ernesto, do we have your audio on? Maybe not. So let me follow on with you on that, Michael.
Sure.
The example you gave is spot on, but not all engineers are expert systems engineers. How do you overcome their natural reluctance to work with and understand systems models?
Well, I think that the trick is to not be afraid, right? And again, I every time I see someone try to train everybody in this, it doesn't really work great. So I think what we need to do is allow people that have the inclination to be able to craft and develop these models to do that, what they do well, just like not everybody is necessarily a crack CAD designer, but that other stakeholders and engineers can't be afraid to participate. And in my experience, finding that killer app, that relevant piece of info that then makes it better for that person, then they willingly participate, and then you get this virtuous cycle that Ryan Noguchi from aerospace always talks about. And so, I worked on a program where we had a hazard database, and that guy was happy. He didn't have to maintain a separate access database of the functional hazard analysis. We brought it right into the system model. It was tightly coupled with the architecture, and then using simple rules about, what messages were safety critical based on hazards, we rapidly found, subject matter expert one thinks that this message should be safety critical. It's not flagged that way as part of our rules. Either they're wrong and it's not in this system, or we're missing a hazard. And you get this very rapid interplay between the disparate disciplines because we're working with this common data set, and it really helps inform that. So the trick is to really uncouple what you need to do from how you used to do it, right? The answer isn't printing out a wall-sized chart of the interconnects so you can trace them with your finger. It's asking the system modeler for a table of what's connected to A. A is connected to whatever. And so it just, again, it lets us get this tempo where we can deliver results at the speed of relevance that's impossible to get with analog processes.
And Denise, what about
I
you
think,
at Lincoln Labs?
yeah, I think, to answer the question about that fear of adoption of a new technology, um, I like to break it down that there are three types of thinkers. There are strategic thinkers, there are operational thinkers, and right in the middle, there are tactical thinkers. So the strategic thinkers, you say to them, hey, I have this great new idea, this new technology. It's going to tie us all together and make us see the issues before they happen. And we're like, go for it. That makes sense. You get the operational people who are those supermodelers or those CAD designers, and they understand the technology and they say, no problem. So it's that middle layer. It's the people who are not, they don't understand the tools, they don't understand the domains. You have to show them that they're driven by risk. So if they see a new technology as a risk, you have to show them that it's an advantage. So you need those strategic thinkers to start pushing on, no, come on, guys, this all sounds like the right way to go. You need the operational thinkers to start to say, this is how we can use these tools. Look at what we can do. And if you can show that and show those small gains and show those successes in the middle, then you start to buy down that risk for those tactical thinkers, because those are usually the people who are driving the whole project. So it's really thinking about who the people are in your organization and what speaks to them and how to address those challenges. Modeling itself is just a natural evolution of the world and digital technology. So, how do you make people comfortable with adopting it is really the challenge.
And I think along Denise's line there, again, not everybody needs to be a red hot modeling jock, right? But if they can understand what it can do for them, and you meet every stakeholder where they're at, as she said, help buy down that fear. And again, I've never seen modeling make things worse, ever. It always exposes holes or gaps. I mean, I had an Excel spreadsheet for pinouts for a cable I was asked to model, and that spreadsheet wasn't in sync between the first tab and the eighth tab. And what's ground truth? I mean, so just getting people to work from a common playbook is a huge step forward. And then when they realize that this isn't scary, and I don't have to learn every aspect of the language. The rule I've always had is the SME owns the data, the modeler owns getting it in the model, and they both have to agree. And when you get to that fruitful partnership, that's when the wow really starts to happen. And I would ask people, what is it worth to you to detect an error as soon as it happens? Like with our validation rules, if you create a function, it throws a warning, hey, this doesn't occur anywhere. It's not part of a mission thread or a state. Then you do that. Oh, hey, your inputs and outputs aren't mapped to an interface, or you've got a mismatch or thing. I mean, just what's it worth to you to catch a mistake as soon as it happens, as opposed to an integration when you're building something and find out that there's an issue, right? It's awesome to have that kind of power at our disposal. And I did some back of the envelope calculations, and from what I can tell, just automated validation against a rule set is worth at least $4,000 plus per $1 million of project value, just in terms of catching potential mission killing bugs that may leak through to the end and surface way later. So, I mean, there's enormous value in burning down that technical debt and risk just by exposing all this up front.
And at Toyota, what we found was that it's a small subset of the actual full systems model that makes its way into the digital thread. And that grounds everybody that's using that information and attaching other information to it. So as you said, Michael, it's not a matter of showing the wall size chart that shows the entire detail of the systems model, but it's more extracting the essence of it that you can then find useful and give you context for the rest of the work that you do. So
I call
just
that
moving on
a tactical query, and that really, it's whatever that person needs at that moment to solve their problem.
Yep, that makes sense. So in this final section, I'd like to explore the obstacles to evolving from a traditional product or BOM-centric approach to a system-centric approach. So over to you, Denise. What we're discussing here are the practical consequences of applying systems thinking to digital transformation, managing product complexity from a holistic system-centric view. Now, our audience has deep roots in mechanical structures and in BOM management within their PLM deployments. Why is evolving from a BOM-centric approach to a system-centric approach critical? And what obstacles did you face at Lincoln Labs?
and I think we're still evolving, so still plenty of obstacles to come. But if and we started our PLM journey kind of in the middle of the life cycle. So you consider that concept development at one end and the sustainment at the other. We started with detailed design and that the hardware design into fabrication. And we did that because the tools were more developed. Our processes were more developed. We had a greater understanding. But as we went through that implementation, I've seen some of the people on today who worked with us, but probably know I'm going to say this. But the question I kept asking was, well, where does all of the other information go? There's 2 years of work that's done before you ever get to the real detailed hardware design. Where does that thinking and those conversations and those different views of the system and concepts, where does that go? How do I understand the decisions that I made? So if you think about it, we were already systems thinkers. We were already using that. We might do some CAD design as conceptual design, but not detailed hardware design. So how do you take that methodology that you're already using and apply it and say, look, we shouldn't really start with that bomb. It's easy to think of bombs and they've been around forever. But how do we start to harness that decision making that we've made up front in the project before we ever get to that real detailed product view of it? So that's where we're going right now, because that's the question that everyone asks. Everyone wants to know, especially in my business where we do a lot of small projects and we do them over time, and sometimes we want to use technologies or similar designs, and we say, well, did we ever think of this before? How did we do this? How do we look this up? And you can't, because it's locked in a PowerPoint slide or someone's head. So having that system view and capturing that intent, capturing those ideas, capturing those system ideas, all that variance. And I'm sure there's some talks about variant management over the next 3 days, but how do you even capture that? So then the next step is then how do you use it? So taking that system thinking, capturing it digitally, just as the stepping stone to doing more great things in the future before you ever get to the bomb. The bomb just supports, that all of that work beforehand. How did I make sure that, as Michael said, how did I make sure that we thought through the whole system, how I was going to build it, how I was going to test it? Did I think about the requirements? Did I think about the interfaces so that when you try to marry that software with the electronics and the mechanics, that something doesn't go horribly wrong, where then you spend more time trying to figure out the problem versus looking at a model and saying, oh, we missed this. Sure, you're still going to miss things, but you're going to think through it first rather than taking 3 Excel spreadsheets all out of date and email them and have 3 different disciplines working in different areas. So thinking about that is the core of what you do, because that is the core of what you do. And then getting to that bomb, that product view when it's time in the life cycle to get to that product view, but having it validate all of the thinking you did before. That's the key. So that's the transformation. And we've been doing it with paper for years. This is just a better way of thinking about it. So that's.
Well, you would think that it's very natural for engineers to gravitate to thinking about the whole system rather than only about the very narrow part of it that they're responsible for.
You'd think.
So, Michael, just shifting over to you, SAIC is presenting at this ACE conference a case study of how a system model is used as the connective tissue that glues together various domain-specific structures that are managed in the platform. Now, this approach is at the core of the MIT Lincoln Lab initiative as well. So why is that important for not just the systems engineers, but for the entire team? And are there any obstacles you face at SAIC? And
Sure.
we have about 30 seconds to a minute left.
Sure. And I'll say this, Carlos Baldwin's book on design rules says the purpose of test and integration is to capture, previously unknown interactions. And so as Denise said, testing is a big deal, but the better job we can do in the SE up front, the better off we are. So, having this authoritative source of truth about design intent really lets us execute at an increased tempo. We have confidence that we can detect errors early, and getting this trust in the model and finding more uses for it allows everybody up and down the entire life cycle chain, from before the let there be bomb moment to, upfront concept design all the way through sustainment disposal. This common digital representation really lets us get more rigorous analyses and everybody benefits. And that's the key message here, is that by participating in the thread, we all benefit. And as far as obstacles at SAIC, I'm fortunate that I haven't really faced any. I'm part of the strategy, growth, and innovation team that was specifically created to do this. And so we've assembled a team of experts from various organizations that we've poached effectively, and we exist to do this. And I've been fortunate to have support our internal T3 and conferences. I've been a research fellow. So SAIC is really committed to this. And I would, and let's just share things like our validation rules, FMEA, profile, data rights, classification, because we're trying to benefit the whole industry. But the biggest challenge is getting people to uncouple what they have to do from how they used to do it, like I said. And after that, it's easy to get things moving. So I would encourage any organization, find the best talent you can, invest in them, empower them, and let them show you the wow. Just turn them loose, and you'll be amazed at the payoff you can get from digital engineering. Thank you.
Thank you, Michael. And we're pretty much out of time, so I'd like to wrap this up. Systems thinking is an abstract concept, but quite important to the digital transformation process when approached correctly, and if you use the right low-code platform to design and deploy that custom digital thread. Of course, there's no implication that that platform has to be Aris, is there? So all of you, thank you very much. And sorry, Ernesto, we lost Ernesto. His connection was lost. I hope you found this discussion useful. And you can reach any of us while we're here at the conference or later. Thanks all. Bye for now.